Hi everyone. So this is going to be the review lesson for Unit 3, Trigonometry, and we're going to start by building a toolkit of things that I think you would need to answer the questions on this assignment. Then we're going to go through some questions, and then for homework you're going to try an assignment. I will then take up the assignment in the next lesson, and then I will assign the real assignment that we'll use to finish off this unit. So here we go. Let's get started. The toolkit. So in the toolkit, all the things that I think you're going to need. Well, one of the things that you'll need is something that you learned last year or that you've learned in the past, and that is that the sum of the angles in a triangle is 180. So if we were to label this with we're going to use capital letters for the angles, so capital A, capital B, and capital C, and that represents that angle, and that angle. We have known from previous years that angle A plus angle B plus angle C equals 180, and that's a very useful fact for us. It helps us easily to get a third angle if we've got two, so always keep that rule in your back pocket. Okay, the next thing we did was we did some work with right angle triangles, okay, and we did a couple of things. So again, I want to label it again, and I'm going to label this angle A up here, this angle B, and this angle C, and we know that angle C is 90, but we don't necessarily know what the other two angles are. You know, if they were equal, they would be both 45, but we don't know that for sure. Okay, and so I'll label this side. We label the side lengths little letters, so that's little c, little a, and little b. So one thing we do know always about right angle triangles, and we've learned this actually in previous years, is that the two shorter sides we could take those ones and we can go a squared plus b squared. The sum of the squares of the two shortest sides is equal to the square of the hypotenuse. And the angle C, or sorry, side C, which is opposite the 90, is the hypotenuse. So that's the hypotenuse. I'm going to label it hypotenuse. Hypotenuse, or H. Okay. And the other two sides are just the shorter sides. So this is what we call Pythagorean theorem. And again, you're welcome to use that. That's a method that we can use to solve for lengths. But what we learned this year was this idea of the ratios of the sides of a right angle triangle. And what we learned was that there are three ratios that are particularly important, and they're sine, cos, and tan. And then we learned this little method of remembering them, SOHCAHTOA. And what that means is that the sine of an angle is opposite over hypotenuse, the cos of an angle is adjacent over hypotenuse, and the tan of an angle is opposite over adjacent. And luckily, your calculator is pre-programmed with these ratios in them. So let's say we were looking at this triangle and we were interested in angle B. Because remember, whether or not something is opposite or adjacent depends on the angle. So relative to B, this little side here is adjacent. I'm going to label it capital A here and call it adjacent. Okay, and side B would be opposite angle A. So opposite angle A. So there they are. So relative to B, and I'm just going to circle B in a different color because that's what we're focusing on here. Relative to B, this side is the hypotenuse, C. This side is the adjacent, and this side is the opposite. So then we can write over here, sine, that's what the S stands for, is sine. Sine of B is equal to, well, it's equal to opposite over hypotenuse. So the opposite is little b, and the hypotenuse is little c. So look at that. We now have a relationship between the angle and two sides. Well, we know also that cos of angle B is adjacent, so that's, look at that, that's little a, over hypotenuse. Hypotenuse is always c. And then finally, we know that tan of angle B is equal to opposite, so that's B over A. Okay, well, just remember, though, that this changes if we were to look at angle A in this case. So I'm going to pick a different color here. And so let's say we were going to focus in on angle A now. We'd have to change it a little bit. So watch this. Sine of angle A. Well, relative to A, side A is opposite. So here we go. Look at this. It would be A opposite over hypotenuse. Now, the hypotenuse never changes, so it stays as C. So cos of angle A, adjacent. Well, look, there's the B. It's adjacent to the A. And there's the hypotenuse C. So it's going to be B over C. And finally, tan of angle A is opposite. So little a over little b. So you always got to base these trig ratios on the angle that you're looking at. So what's opposite and what's adjacent will change depending on which angle you're looking at. But what we're going to see is that these trig ratios allow us to solve for sides and angles with right angle triangles. Okay, a couple more things in our toolkit. We then spent some time working on something called the sine law. And the sine law can be used for all triangles. Notice that SOHCAHTOA that we just discussed can only be used for right-angled triangles. And so I just want to emphasize that this is only when you see right-angled triangles, whereas the sine law can be used in any triangle. And here's what the sine law says. Again, we're going to label our triangle with capital A, capital B, and capital C. We always label them that way. The side opposite the angle we'll label with the little letter A, little b, and little c. And what we've determined is that there's this new law that says this: A over sine of A. So the opposites, the side A over top of the sine of angle A is equal to B over sine B is equal to C, little c, over sine C. So these ratios hold, and when we go to solve questions, we will focus in on just two of the ratios. We won't use all three at once, but we'll use two of them to solve things. Now, just one quick comment is that you don't have to put the lengths on the top and the angles on the bottom, but you've got to be consistent. So I could actually write it like this: sine A over A is equal to sine B over B, and sine of angle C over little c. So it doesn't matter which way you write it, and it doesn't matter which two you use. Like I could use this one and this one to solve for things. And so it doesn't matter which we use. In order to use sine law, and here's how I'm going to put a little star here. In order to use sine law, you must have a pair of opposite side angle / angle. So in other words, you must have either the angle A and side A, or the angle C and side C. You need to have a pair, and so that's going to be something that you'll look for, because the sine law is easier to use than the cosine law. So anytime you've got one of these available, choose sine law. If you've got angle C and side C, use sine law. And one thing to remember is that right back to number one of our toolkit is that if you've got two angles, you know that you can get a third. So never forget that. Okay, the last thing we learned in this unit was we learned about the cosine law. And so the cosine law is used in a special or two circumstances, and I'll tell you those. So here, let's label our triangle A, B, and C. And so this is little a, little c, and little b. They're opposite, they're angles. And there are two situations. I'm going to put the star up here. There are two situations where you have to use Coase law, that Coase law is required. And what those are is that if you are only given the three sides, you have to use cosine law, or if you are given two sides and what we call the contained angle. Two sides in the contained angle. In those two situations, you have to use the cosine law. So in other words, if you were given side A, side C, and angle B, that's what I mean by you'd have to use. Unfortunately, you don't have opposites, so you can't use the sine law. And in this case, for only three sides, if you were given little a, little b, and little c, you would have to use the cosine law. And what the cosine law is, there's two ways of writing it. It's a squared is equal to b squared plus c squared minus 2bc cos of angle A. And notice that whatever side you have over here has got to be the angle you have over here. The other way of writing it is if you were looking for an angle, I can write it like this. I'm just going to rearrange that equation. Cos of A is a squared minus b squared minus c squared divided by negative 2bc. So there's two ways of writing cosine law. And just so you know, you can write it in other ways. Like I could write it with this side b on its own. So watch this. Here's what would change. It would be b squared is equal to a squared plus c squared minus 2ac and then cos of angle B. So notice how it changes just a little bit depending on which side you put by itself. I'll just write it this way so you can see it as well, is that cos of angle B is equal to a squared, it's equal to b squared minus a squared minus c squared all over negative 2ac. So there's other ways of writing it. All right, well, let's try a few questions here just to kind of get in the groove of this. So here are some easy questions. It just says evaluate those. So you type those into your calculator. So I'm going to do it on my calculator. For mine, I hit sign first, and then I type in 35. First of all, I'm going to put a little star up here, which is make sure you're in degree mode. Make sure your calculator is in degree mode. So whether you're using a cell phone or an actual calculator, make sure you're in degrees. So again, some calculators you type 35 first and then hit the sign button. On the one I'm using, I type sign first, I type in 35 and I hit equals, and what that I get is 0.574. I get actually 573, 576, 436, but I think going to 3 decimal places is a good ballpark. Okay, well, here's another one, 10. This is another one of our primary trig ratios. I type in 10 of 72, and I get a number of 3.07768. So I'm going to go 078. I'll go to 3 decimal places. Okay. Well, we can also undo this, and this is a common thing we have to do in trig, is if you know that the cos of the angle is this number, so that's the ratio, but if I wanted just theta, I use the second function, or the inverse of 0.1339. So watch this. On my calculator, I go second function, cos, and it gives me this cos with a little negative 1. And then I type in 0.1339, and I get an angle of 82 degrees. It says to the nearest degree, so I'll go, it was 82.3, and because that wasn't above, the 3 wasn't above a 5, I just keep it at 82. And just one quick note here is that in these questions, you'll often, the numbers will be maybe a little bit off based on rounding. I'm not going to be worried about it. So just be aware of that your answers may sometimes differ a little bit from mine. You don't need to worry. Okay, so here we go. In this one, I've got to do the inverse tan of 3.4511. So I go in my calculator, I go second function tan. It gives me the little tan with the -1. And then I put in 3.4511. And I get 73.8. So I'm going to say roughly 74. Maybe I should put a little approximate sign there. Okay. Here we go. Let's try. So there's some simple ones. This one says, find the trig ratios in this for theta. So this is good. So they just want you to be sure that you know. So I'm going to label the triangle relative to the theta. This side, 15, is the hypotenuse. The 12 is the opposite, and the 9 is the adjacent. Theta is, or 12 is opposite the theta, 9 is adjacent to the theta, and the 15 is always the hypotenuse. So then I would write it like this. So sine of theta, I know based on so is opposite, so it's 12 over hypotenuse is 15. That's all they're looking for here. So here we go, cos of theta. Well, I know that that's ca, so it's adjacent. It's 9 over 15. And then tan is toa. So tan of theta is opposite, 12 over 9. Opposite over adjacent. Okay, so just writing some of these trig ratios. Okay, let's try another question. Here, we're going to use our SOHCAHTOA and to solve for things. So in this case, they want you to solve for a side. So again, here we go. So relative to the 38, this side is the side that we're looking for. The unknown is it's adjacent to it, and the 12 is the hypotenuse. So I'm not given anything about the opposite. I'm given something about, or I need something about the adjacent. And so when those are the two involved, when I see A and H, I see so, ka, toa. I kind of go, well, look, there's the A and the H. So clearly I'm going to focus in on cos. I don't need sine or tan. So watch what I'm going to write. I'm going to write cos of 38 is adjacent, which is my unknown, so it's x, over the hypotenuse, which is 12. There you go. I've got a way of solving for my x. And now I just have to rearrange and get x by itself. And it's nice that it's on the top here, so I don't have to worry about getting it to the top. I just have to get rid of this 12. And so what I'll do is I'll multiply this side by 12. But whatever we do to one side in math, we've got to do to the other. So 12 over 12 is 1. And so that gets rid of it. And so my x is going to be 12 times cos of 38. I'll go to my calculator, and I'll type 12 times cos 38 equals, and I get an answer of 9.456. I'm going to round it to 9.5. And to give me a unit there, centimeters, 9.5. So x is equal to 9.5 centimeters. And let's have a look. Does that make sense? Sure it does. It's close. Like in terms of my triangle, remember, triangles aren't always drawn to scale, but at least I know that it's less than the hypotenuse. It makes sense. Okay, in this second one, they're asking you to solve for an angle. So look what I'm going to do. I'm going to look at this, and I'm going to say, well, relative to this angle, the 11.2 is the adjacent, and the 8.6 is the opposite. So again, I'll consider here so, ka, toa. and I'm given the opposite and the adjacent. So let's focus in on tan. I'm not going to use sine or cos. So tan of theta is 8.6. It's the opposite over the adjacent. Okay. And so here we go. In order to, I'll do that first. So tan of theta, and I'm going to divide it here, 8.6 divided by 11.2, and I get 0.76785. I'm going to go 768. I go to 3 decimals. Okay. And then to get the actual angle, I got to do that inverse function. So inverse tan of 0.768. Second function, tan, and I get approximately 37.5 or 38 degrees. You may be a little bit different. I kept all of my decimals there because it was just easier for me to do that. Okay, let's try another one here. Well, this is an application question. I thought this one was good because it shows you that you can, you got to use the tools you've got. So Chloe has lost track of time. She'll get in trouble if she is late for dinner, but she will get in more trouble if she comes home with wet shoes. Racing home, Chloe encounters a creek as shown. Glancing at some nearby rocks, so these circles are meant to be the rocks. Okay, so glancing at some nearby rocks, she estimates the distances indicated. Chloe can jump about 2 meters. Should she try to jump the creek or take the long way over the bridge? So the bridge is way down here somewhere. So I guess the question really we're being asked is, that looks like, can she jump from that rock to that rock? Well, so in order to solve this, we need that distance right there. So in other words, is that little x right there, is it less than 2 meters? Okay. Well, you may think, well, how are we going to get there? Well, because we only know this side is 1.5. We don't know what x is here. But look at this. Within this right angle triangle down here, because look, of that little square there, we know that this is a right angle triangle. We can get this angle. And so I'm going to label that angle theta. And we know that this is adjacent to that angle, and this is opposite that angle. So let's start by getting that angle. So I'm going to come down below here. And I know SOHCAHTOA, so tan of theta is opposite over adjacent. So in this case, tan of theta is 0.6 over 0.5. Okay, and so here we go. 0.6 divided by 0.5 is equal to 1.2. So theta is the inverse tan of 1.2. And so I'll type that in. Second function tan of 1.2. Oh, it's roughly 50 degrees. Okay, but look at this. We know from last year, opposite angle theorem says that if this is 50 degrees, that this must be 50 degrees. So we know an angle in this other triangle. And look at this. I know that in this other triangle, this is adjacent to the 50, and this is opposite the 50. So watch this. Tan of 50 degrees is equal to opposite over adjacent. That's TOA. So opposite is x, and adjacent is 1.5. And so that x right there is 1.5 times tan of 50. So we were able to use some right angle triangles to get this. And so here we go. I'll go 1.5 times tan of 50 equals, and I get a number of 1.787, so I'll say 1.79 meters. And so therefore it's less than the 2 meters, and so I'll say since x is less than 2 meters, What was her name again? Her name was Chloe. Chloe should jump the creek. Should jump the creek. Okay, so there you go. We've used, that's a good application of right-handed of right triangles. Okay, well here are clearly some non-right angle triangles. And so let's give these, this one says solve for angle theta. And so here we go. Right away, I notice that we have opposites. We have 29.5 and we have 44, which are opposites. So I immediately say I'm going to use sine law. So this side is little a, this side is little c, this side is little b. And so right away I go, well, a over sine a is equal to b over sine b, which is equal to c over sine c. Okay, so let's plug in what we know. We don't know anything about a or sine a, so I'll just leave them like that. But look at this. For b, we know that it's 29.5 over sine of 44. And for c, it's 37.1 centimeters over sine of theta. And there it is. So we're going to focus in on two parts here. And clearly we're going to use the one where we know both of the ratios and one where our unknown is. And so look at this. I'm going to quickly rearrange this before I solve anything. And we have this little technique where, look at this. I can cross multiply. I'm going to multiply my sine theta up there. And I'm going to multiply my sine 44 up there. And so you end up with 29.5 sine theta, just by cross multiplying, equals 37.1 sine of 44. Okay. And then I want sine theta by itself, so I'm going to divide the 29.5 off that side, but whatever I do to one side of math, I've got to do to the other side, so I'm going to divide there. That gets rid of it. And so there you go. I've got sine theta now on its own and on the top. All right, let's do this, figure this out then. So 37.1 times sine of 44 divided by 29.5. I've done that in my calculator and I get 0.8736 or 874. And now to get just the angle, I've got to do that inverse sine. So theta is the inverse sine of 0.874. So I go second function sine, and I get roughly, approximately 61 degrees, 60.88. Yours may be a little bit different. Okay, over here it says find the value of x. And then look at this. Here I've got no opposites. So clearly this one is going to be a cosine law. I don't have the angle opposite the 15. I don't know why. I don't have the angle opposite the 18. And clearly what I'm looking for is the opposite there. So this one is going to be a cosine law. Now they've already labeled it with little x's. And so I'm going to keep those. I'll just label this one as a little z, and I'll label this one with a little y. And here we go. I am going to write x on its own. And cosine law would look like this. Little x squared is equal to little y squared plus little z squared minus 2 little y little z cos of angle capital X. So that's, it's just writing it. I know it's not using A's and B's and C's, but basically I'm just trying to show you that it doesn't really matter what the letter is, but notice that whatever side is here, the angle has to be here. All right, so here we go. Let's plug our numbers in. 15 squared plus 18 squared minus 2 times 15 times 18 cos of 46 degrees. Okay, so here we go. I'm gonna do this. I'm gonna do it gradually. 15 squared plus 18 squared equals, and so here I get 549. Try that out. Minus, and then I'm going to do that next part. 2 times 15 times 18 times cos of 46 equals, I get 375.11 there, okay. Sorry, 0.115, so I'll go 0.12. And now 549 minus 375.12, and I get 173.88. But remember, that was x squared. So now I do the square root of both, and I do the square root, and I get roughly 13.2. Okay, and it was centimeters. Okay, so there's an example of the cosine law. Okay, just a couple of more here. Yeah, here, we'll just do a couple of application questions that involve the sine and cosine law, and I want to show you this one. It says angle measurements were taken from 2 points opposite sides of a tree. How high is the tree? Well, the reason why I want to do this one with you is that, so does everyone agree that we're looking for that height right there? I've kind of drawn it on the triangle, but notice that unfortunately, I don't know. I could use SOHCAHTOA if I knew that side or if I knew that side. But unfortunately, we don't. In fact, we know that it's not the middle. So I can't just divide the 65 in two. So what I'm going to do is I am going to start by working with this whole triangle. I'm going to do it in green here. I'm going to work with the whole triangle. And interesting, I'm going to pull it out of there just for a second to show you this, is that technically we know that this is 35, we know that this is 30, but because the sum of the angles in a triangle is 180, we go 180 minus 35 minus 30. And look, we know that this is 115, and we know, we know that this is 65, the entire length. So watch, we know an opposite. And so I can use this to get this side over here. And I'm just going to label it. Look at this. If I call that capital A, capital B, and capital C, that's little a, that's little b, and that's little c. I want to get b. And I'll show you why in a second, is that once I get b, look what I'm going to be able to do. I am going to be able to use SOHCAHTOA, because I'll know, if I know this side right here, and I know this angle is 35, I can get the height of the tree. So there's the plan I'm going to use. So look at this. I'm going to go back to this one. Let's use sine law. So I'm going to go little a over sine of A is equal to little b over sine B is equal to little c over sine of capital C. Let's plug in what we know. A over sine of 30 is equal to b over, oh, sorry about that. I made a little mistake there. Let me go fix this. That was a over sine of 35. A over sine of 35. Notice that a is opposite the 35. B over sine 30 is equal to 65 over sine of 115. And I said, well, let's work on b. So I'm going to work on this part of my sine law. So here we go. Look what I'm going to do. I'm just going to say b is equal to, and I'm going to multiply the sine 30 up. So it's going to be 65 sine 30 all over sine 115. So that was nice. And so I can go 65 times sine of 30 equals, divided by sine of 115. And I get an answer of 35.859. I'll go 35.86. Okay, and that was, the original triangle was all in meters, I think. Yeah, so that's meters. So look at this. Now I know that that is this side over here. And I'm going to write it in there now as 35.86 meters. That was this side of the triangle, so I was allowed to move it down. And because the tree is at right angles, I can now use SOHCAHTOA. That's a little bit easier. So watch this. I can say that sine of 35, I'm focusing in on this triangle, is equal to opposite, which is the height of the tree. And I know that maybe using h confuses people with hypotenuse, but that's the height of the tree over the hypotenuse, which is 35.86. It's opposite the right angle triangle, or the right angle. And so now h is going to be, I just multiply the 35, so 35.86 times sine of 35. And just so you guys know, again, I'm talking about cross multiplying, but really it's the same thing we've been doing. It's 35.86 times this side, but it's also 35.86 times this side. So it's the same idea of isolating a variable. And so here we go, 35.86 times sine of 35, and we get a height of 20.568. I'm going to say approximately 20.6 meters high. So there you go. That's a nice application where you have to use both sine law and SOHCAHTOA. So it's two different things within the same one. And so remember that you can do that. Okay, one last question here. It says, if you're given a triangle FGH with sides, little f, little g, and little h, determine the measure of the smallest angle. Include a diagram. Okay, so this is an interesting one where, again, you've got to draw the triangle. So I can see right away that this f is the longest one. So I like drawing it. I'll draw it along the bottom. So there's the 12.6 meters. The other two sides are shorter. And so clearly, look at this. I'm going to draw, and I'll label this one little f. And so I'm going to draw there, I'm going to draw 8.5. I'll call that little g is 8.5 meters. And then this one is the shortest side. And so little h is equal to 6.3. All right, well, I'm going to label the angles now. That's capital H because it's opposite the little h. That's capital F, and that's capital G. So they want me to get the measure of the smallest angle. Well, clearly, the smallest angle is going to be little h. It's going to be opposite the smallest side. But I look at this and I go, well, all I've been given is sides, and so I know I've got to use cosine law. That's one of those two circumstances where you've got to use cosine law. So here I go. I'm going to write cosine of h. All right, well, what that's going to be equal to is going to be h squared, little h squared, minus little g squared, minus little f squared, all over -2 times g times f. Now, some of you, again, may prefer to work with a's and b's, and that's fine. Like, you may actually decide to relabel this triangle. You may label this one capital A, and this one little a, and you just because you're comfortable with that, you may label this one capital B and little b, and this one capital C and little c. And in your books, you would have looked at it and said, okay, well, cos of A is equal to a squared minus b squared minus c squared over -2bc, and you would have got the same thing. So don't worry, if you'd like to relabel the triangle, if that's easier for you, do it that way. So here we go. I'm going to plug my numbers in, and I get 6.3 squared minus 8.5 squared minus 12.6 squared all over -2 times 8.5 times 12.6. Okay, I'm going to gradually do this. So type it in. 6.3 squared minus 8.5 squared minus 12.6 squared. And there I end up with negative 191.32 on top, and then on the bottom, it's negative 2 times 8.5 times 12.6. I end up with negative 214.2 on the bottom. So a negative divided by a negative is a positive. So I end up with negative 191.32 divided by negative 214.2, and you end up with 0.893. But remember, that was cos of h. Okay, so then h is going to be the inverse cos of 0.893. So I do second function cos, and I get roughly 26.72, or approximately, let's say, 27 degrees. So there's an application question that involved cosine law. Okay, so again, I'm going to just a couple quick hints for the coming assignment that I'm going to give you. If it ever gives you the angle of depression, so in other words, look at this. If I was standing on a building, if I was up here on the building, and if it said the angle of depression, so it would be, if I was looking out like this right here, that theta is what we call the angle of depression. It's not about being sad, it's the angle as you look down. So that would be the angle of depression. So just that's one thing that would help. And just remember that if your answers aren't exactly the same as mine, if you're a little bit off, don't worry about it. All right, so I'm going to have you guys try the assignment for homework. We're going to take that up on Wednesday. And then on Wednesday, I'll give you your real assignment that will close off the unit. Take care, everyone.